ideas about the fundamental forces, exchange particles, and also particles and antiparticles. So we'll have a look at all of those. So it's asking you to give an exchange particle other than the W plus or W minus boson, which by the way is the exchange particle for the weak interaction or the weak nuclear force. Another type of fundamental force is the strong interaction, and the exchange particle for that is just the pion. It can be a pi naught meson, a pi plus meson, or a pi minus meson. Either one of those would get you a mark. By the way, another type of fundamental force is the electromagnetic force, and the exchange particle for that is a photon. Exchange particles, what they actually do is they transfer energy and they transfer momentum from one side of an interaction, say the left hand side of an interaction, to the right hand side of an interaction. That's their purpose. So they transfer energy and transfer momentum. That would get you 2 marks for that. Before we have a look at these questions, this question, I'm just going to remind you that all types of particles can be split up into hadrons and leptons. If you'd like me to go through the differences between these, just let me know in the comments and I'll make a separate video about that. And leptons, they're what we call fundamental particles, so they can't be split up anymore. They're not made of quarks, so they can't be broken down into quarks. Whereas hadrons can be split up into baryons and mesons. Examples of baryons you need to know are protons and neutrons. Examples of mesons you need to know are the K mesons and the pi mesons. Examples of leptons you need to know are the electron, the neutrino, whether that's an electron neutrino or a muon neutrino. They're both leptons. And also a muon. This one you might be unaware of. So let's fill these in step by step. A proton is a baryon, so it is a hadron. Is a proton a lepton? No. So we don't include it in that list. It is an antiparticle? No, because an antiproton would be an antiparticle. Is it a charged particle? Yes, because it has a charge of +1. Now let's go through an antineutron. Is it a hadron? Well, technically it's an antibaryon because it's an antineutron, but it still falls under the category of baryon. Sorry, hadron. So yes, it is a hadron. Is it a lepton? No. Is an antineutron an antiparticle? Yes, it is. Is it charged? No, because a neutron has a charge of 0 and an antiparticle has the opposite charge, but the opposite of a neutral charge is just neutral. Now for a neutrino, this is an electron neutrino. That's what the E on the bottom right means. That just means that it's the neutrino that is produced with an electron. So a neutrino, is it a hadron? No, because it's a lepton. So we put in the lepton column, or row, sorry. It is an antiparticle? No, because an antineutron would be an antiparticle. Is it charged? No, because an antineutrino actually is uncharged and it has almost 0 mass. Now this is a positively charged electron, which we call a positron. Automatically that means that it's an antiparticle because it's the antiparticle for the electron. So it's under the leptons column, so it's not a hadron. It's in the lepton column, like I mentioned. So the antiparticles still fall under these sort of lepton columns. Is it a charged particle? Yes, it has a charge of +1. Now a muon, well, a muon is a lepton, so it's not a hadron. It is in this column. It's not an antiparticle because the positively charged muon, an antimuon, would be the antiparticle. Is it charged? Yes, it has a charge of -1. This one is a bit tricky, the pi naught meson. It is a meson, so it falls under the category of hadron. It's not a lepton, but it's also not charged. But the antiparticle, it actually is an antiparticle because What's the definition of an antiparticle? It's something that has the same rest mass but is oppositely charged. For example, a proton and an antiproton, they both have the same rest mass. If you check that, you can check that online if you'd like. They both have 931.8 mega electron volts, but they're oppositely charged. This is positively charged, this is negatively charged. But the opposite charge to a neutral atom is just that charge itself. It's just zero. So this is its own antiparticle. This only applies with a pi naught meson and a k naught meson. So these two particles, their antiparticles are themselves. Hopefully that makes sense, and thanks for watching. If you have any questions, please let me know in the comments.